So for 6-2 homework assignment, problem number 13 here are the two proofs from that assignment. All right, so this one, we want to prove some of those theorems. The first one, that AC and BD bisect each other at point E. So remember, we can divide this up into triangles. So ABCD is a parallelogram, and that is given. Our definition of parallelogram tells us one thing, that opposite sides are parallel. So I'm going to use definition of parallelogram. Now, angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. Those guys are alternate interior angles. AB is congruent to DC. Again, opposite sides of a parallelogram are congruent. And then we can use angle side angle to prove that triangle BEA is congruent to triangle DEC by angle side angle. And then once I've shown two triangle congruence, all of their parts are congruent. So the corresponding parts of congruent triangles are congruent. And then you finish with what we're trying to prove. AC and BC bisect each other at E. Remember this one. This one is the last thing we're going to look at in our notes today. So what we've done in 6.2 is shown all of the different properties and proven the properties of parallelograms. Today we're going to use the converse to prove that a quadrilateral is in fact a parallelogram. All right. Next one. This one is one of the easier ones. Our statement and so we're starting. We're given a parallelogram. Two AB parallel to BC and BC parallel AD. That's by the definition parallelogram. And then we're all done. Angle A is supplementary to angle B, and angle A is supplementary to angle D, because those guys are same side interior angles. All right. All right, so today's lesson, we want to show that quadrilaterals are in fact parallelograms. So we're going to use the converse of each of these to show that quadrilaterals are parallelogram. So first, let's draw some pictures. If both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. So let's draw this picture. So opposite sides, if I can show both opposite sides are congruent, then I can prove it's a parallelogram. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then it's a parallelogram. Let's see what this one is. So if I have A, B, C, D, if the measure of angle A plus the measure of angle B equals 180, and if the measure of angle A plus the measure of angle D equals 180. So it'll be supplementary to both A, supplementary to both B and to D, then we know that it's a parallelogram. If both pairs of opposite angles are congruent, then it's a parallelogram. So we have opposite angles here. Both pairs of opposite angles are congruent. And if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. So we actually looked at that and we proved that in the homework. This one, we have those diagonals, and those diagonals chop together or meet at each segment's midpoint. So if two segments bisect together, they cross each other at the midpoint. And then this one's a new one that we didn't look at in the last lesson. If one pair of opposite sides of a quadrilateral are congruent and parallel, then it's a parallelogram. So if we have something like this. Parallel and congruent. All right, so for the next ones, for example 1, I'd like you to look at those examples A through E and C, say yes or no whether or not there's enough information to show it's a parallelogram. And if it is yes, pick either 6'8", 6'9", 6'10", 6'11", 6'12 to match up that reason why. All right, I'll give you a few minutes for that. Here we go. Recording. So, this first one, is there enough? Yes. What reason? 6.12, right? We have a pair of opposite sides that are congruent and parallel. What about this one? What's the reason on this one? 6.8. Both pairs of opposite sides are congruent. This one, you guys have something like this, right? Do we have enough information on this one? Yes, we do. All right, let's think about this one. We know that the sum of two congruent angles will create a congruent angle. So these guys are both congruent. And then our triangle third angle theorem tells us that if two angles of a triangle are congruent to two angles of another, then the third angle are congruent. So those red angles are congruent. So opposite angles are congruent. So this one is congruent by which one? 6.10.
I was right, Sophia.
Remember, I am recording. 10. What about this one? B. Enough information? No. So let's remember, if we do say no, what's our counter example? What if we had something like this? I'll make it extreme. But if we had an isosceles trapezoid, that's not a parallelogram, but it has something like that picture. Right? So it has to be the same side that's both congruent and parallel. And then this one, we have consecutive angles that are supplementary. So we get those add to 180. And then these down here add to 180. So this is yes. 6.9. This is the type of problems you're going to have to solve for on this particular learning target on the test. What value of x would make this a parallelogram? Well, we would need something where consecutive angles are in fact supplementary. So 4x plus x equals 180. 5x equals 180. X equals 36. So what would these angles actually be? I know it does math, but might as well. This would be 36. And this would be 144 degrees. All right, so take a second and graph these points. Label them and make sure you write the coordinates on the graph. Then we're going to discuss this. 2, 1. Or 2, -1. There's A. B. 1, 3. C. 6, 5. And D. 7, 1. Parallelogram ABCD. All right, so I want to prove that ABCD is a parallelogram in the coordinate plane. So let's go ahead and take a look at all of our reasons above and see if we can come up with a plan of how I can do that. So remember, I have a couple of things. I have the idea of slope, right? I can calculate slopes, right? Rise over run, or y2 minus y1 over x2 minus x1. Can I also calculate the lengths of sides? I can use my distance formula. So I have a couple of things in the coordinate plane that'll help me. Can I use my midpoint formula for anything? Good, Aries. So find the midpoint of opposite vertices. We call that the diagonal. The midpoint's the diagonal. So it turns out if the diagonals each have the same midpoint, that means they cut each other in half. And if they cut each other in half, they bisect each other, then it's a parallelogram. So my midpoint formula, right? That's where we add our x's together, divide by 2. Add our y's together, divide by 2. And we find that midpoint. If it's the same, we can go ahead and say it's parallel. So let's go ahead and take a look at our list above. Let's scroll all the way back to the top. So first, does anyone remember the very simple definition of a parallelogram? Quadrilateral, so it has 4 sides, and then what about the 4 sides that makes it parallelogram? Opposite sides are parallel, right? So by definition, a parallelogram is simply a quadrilateral with opposite sides parallel. These are all the other things we proved based on that. All right? So, in my coordinate plane, could I use that definition to show opposite sides are parallel? Sure, I could check the slopes. If opposite sides have the same slope, I know they're parallel, and will never intersect. So there's one way I can use the definition. Could I use 6/8? Both pairs of opposite sides of the quadrilateral are congruent, then it's a parallelogram. Hey, I could use my distance formula to find the lengths of all the sides, and if opposite sides are congruent, it's a parallelogram. Good, so I could use 6/8. 6/9 and 6/10 deal with angles. Can't do that quite yet, unless it's a rectangle or a square, right? I don't have the skills in my basket of skills that will help me find metric of angles. We'll look at that in second semester when we get into trigonometry. We'll be able to calculate angles. Next, we discussed if midpoints are the same with the diagonals, then they bisect each other. So I could use 6/11. It's probably the easiest way. And then I could also use 6/12, calculate slopes and lengths of sides, see if they're parallel and congruent. So the only ones I can't use right now are these two. All right, so let's go ahead and take the path of least resistance. I want to see if ABC and BD have the same midpoints. Let's use that midpoint formula and see if the diagonals bisect each other, thus proving it's a parallelogram. All right? So I'll do the first one, have you guys do the second one. So the midpoint of AC, I'm going to add the x's together. So the x of A, 2 plus the x of 6 divided by 2. And then the y of A, -1, plus the y of C, 5, divided by 2. So that's 8 divided by 2, which is 4. 4 divided by 2, which is 2. There's the midpoint of AC. Take a second. Find the midpoint of BD. See if you can use that formula. This is the easiest way to show something is a parallelogram in the coordinate plane. So take a second. Give that a whirl. So this one, I'm going to add the x's together. 1 plus 7 divided by 2. Add my y's together. 4 squared or 3 plus 1, divided by 2. And I get the midpoint of BD. 8 divided by 2 is 4. 4 divided by 2 is 2. The diagonals have the same midpoint, therefore they bisect each other. ABCD is a parallelogram.